Hello and welcome to Steps to Maths. In this video I'm going to be introducing you to some of the issues associated with factorizing. Okay, so this is an overview of some of the issues you may come across while you're factorizing, and although you haven't actually done the factorizing yet, it's not a bad idea to have some of these in the back of your mind, and it will also be useful to look at these when you're revising. So some of the common issues I'd like to look at is when you're grouping, which is one of the factorizing methods. The idea of unitary grouping. The second issue is when you come across negative numbers in grouping, and the rearranging issue. The third one that I have to look at is the assumption that something is factorizable. So often when you get so used to following a particular method, you just assume things are meant to be in a particular way instead of doing the steps that you're supposed to do. So make sure you're doing the steps that you're supposed to do when you're factorizing. The fourth issue is assuming something's a trinomial. Again, because you spend so much time practicing trinomials, you forget sometimes that they're not trinomials. And the fifth one is another assumption to do with trinomial. So we'll be having a look at all of these issues of factorizing and probably a sixth issue as well. So, unitary grouping. So grouping is one of the methods that we use to factorize. So for example, when we've got four terms, grouping means we break them up into two different groups, the two terms on the left and the two terms on the right. Because there's no common factor, that's what we do first, and then we break those down, we factorize those, and then refactorize again to bring it into a single factor. Okay, you'll come across this when you're factorizing. You factorize from four terms down to two terms down to one term. So we have four terms, and we take the left two terms and factorize them to get a times 3x minus 2y. But we don't know what to do with the two terms on the right hand side because there's no common factor. So what we do is we say we have one of these things on the right hand side. So I have the two terms on the left factorized to get 3x minus 2y, and I have the two terms on the right factorized by saying that I have one of those things. So that's where that plus 1 comes from. Now you can see that we have another common factor, 3x minus 2y, so we can factorize again from two terms down to a single term, a plus 1 times 3x minus 2y. So that's what grouping is about. It's about separating four terms into two groups of two terms, factorizing those, identifying another common factor, and factorizing again to get a single term. Okay, and a little tidy up to get rid of some of the extraneous pluses. Right, the next issue I want to have a look at is again with grouping and the idea of problems that often come across with negative numbers. Okay, so what people often do is they factorize the first two terms, which is fine, and when they come across the second two terms, they assume because there's a minus on the third term that the factorizing is going to be a minus. So they put the minus 2 down and they continue factorizing. So this is all correct so far. The problem now is that there isn't a common factor to those two terms. And because people practice a method, they assume that there should be a common factor and just write down the first factor that they had, the 3x minus 2y, even though it wasn't in the second term. So that's wrong. You cannot do that. Okay, so what I would recommend is that if you come across a mixture of pluses and minuses when you're grouping, is to rearrange those terms. So rearrange the terms so you've got the pluses followed by the minuses. So when you have those four terms, rearrange them so that you've got the plus 3x and the plus 6x first, and the minus 2ay and the minus 4y in the second group. Okay, so if you're grouping and there's pluses and minuses mixed together, group your pluses and group your minuses and then factorize them, and you're less likely to make a mistake. Okay, so you follow with the minus 2y, which is a factor, common factor to the third and fourth term. And now we have a common factor, a plus 2, so we can factorize again, and you would have your solution. Okay, the next issue is assuming something is factorizable. So we've put our pluses and our minuses together, and we factorize. 3x goes in a plus 2 in the first term, minus 2y is common to the second term. And what often happens now is, again, people assume, because the method normally is that you will have a common factor, people assume that there should be a common factor. But 2y does not go into 6y plus 2 times. It goes in plus 3 times. So that on the right hand side, where that plus 2 in red is, there should be a plus 3, which means there would not be a common factor, which means it's not factorizable. Okay, now most of the questions, if you're asked to factorize, they will actually be factorizable, but the problem is that I want you to watch out for is the assumption that the method just continues just the way it is. Okay, so please make sure that each step actually works, that you factorize the two terms on the left, you factorize the two terms on the right, and you don't just assume that there will be a common factor. There should be a common factor if you're asked to factorize it, but the issue is to check where you may have made a mistake earlier. Okay, so this particular question, it's not factorizable and you can't continue because there isn't a common factor. Now, trinomials. Trinomials require a trick to factorize them, which as a result means that you practice them quite a lot. And because you practice them a lot, the problem is anytime people see x squared anywhere, they assume it's a trinomial. Now a trinomial has 3 terms. This does not have 3 terms. It is a simple common factor x. Okay, that's an issue. Unordered trinomials. Again, because people practice trinomials so much, they see 3 terms, they assume everything's good because there's an x squared, an x and a number in it, and they just continue and they write their answer straight down saying the numbers I'm looking for are plus 3 and plus 2, which they're not. Okay, when you're factorizing a trinomial, you need to put them in order first. So in order of powers of x's, so x squared first, followed by however many x's you have, followed by whatever units you have. Now that's in order, we can apply our method. And I would suggest you continue practice the grouping method for this for quite a period of time. It doesn't take long to do and means you're less likely to make a mistake. Okay, so the trick which I come across for factorizing trinomials is you split the middle term so that the coefficients of x, the plus 1 and the plus 5, multiply to give you the same coefficients of the other 2 terms. Okay, you factorize them as a grouping, as normal, and again you've got a common factor and you get your result. Okay, the final issue, another issue that I added on that I'd like to have a look at, is the assumption that something's an equation. Again, because we spend so much time trying to solve quadratic equations, which is when you have a trinomial equal to 0, or some power of x squared, some x squared equal to 0, because we practice that so much, and our method is to factorize and then solve the equation, what happens is when people see an expression, they factorize it, and because they've practiced solving equations for so long, they try to solve an equation. But an equation has an equal sign in it. There is no equal sign in this question, so you should not be trying to solve anything. You were just trying to factorize it. Okay, so there are the various issues that I'd like you to have a look at, but the main one really is not to assume that something is true because you're following your method, right? Your method should be that each step is valid, each step works as you go along. Okay, so watch out for a few of them.